Hi everyone, welcome to this new video, and today it's going to be a crash course on the Kaplay library. So Kaplay is a library for making games in JavaScript, and in this video we're going to go over the various concepts of this library. And it's not going to be the usual project-based tutorials, but if you're interested in more project-based tutorials where you learn the concepts as you go, feel free to watch my previous video. So I have prepared a list of concepts and things I want to talk about regarding Kaplay. So this video is more meant to be watched as something that you watch passively and you refer to later on. So here we go. So first of all, I'm on the Kaplay.js website, and this Kaplay.js website is very important because this is where you're going to see the documentation and access to the playground, etc. So it's not fully complete yet. So before continuing, I need to explain more in detail the origin story of Kaplay. So Kaplay was previously called Kaboom.js, and Kaboom.js was a library for making games, which was maintained by Replit. If you watch my previous video on the topic where I explain why the rebrand, you're going to see that there's a bit of context here. But for now, it's the same thing as Kaboom, but with just a new name. So let's jump right into the installation process. So to install Kaplay, there are many ways, and I'm going to talk about 3 ways. And I think there's 2 ways, I think there's like 2 ways mentioned here, or 3. So anyway, I think both the 3 ways are going to be mentioned. So you can use a package called create Kaplay to create, maybe I should increase the font size. Here we go. So you can use a package called create Kaplay to scaffold your Kaplay project. And I personally don't use this method simply because it uses ESBuild as the bundler, and you have to refresh manually your browser to see the changes. I prefer to use Vite, which is another bundler, but this option, if you're a beginner, you're just starting with npm and you don't know this bundler, etc., it's a very straightforward way of using. So it's a CLI tool. So if I think this just will point towards the package on npm. So if I open that up, you can see the various options. You can add TypeScript, you can even add Tori, which is a technology I used to make the desktop game tutorial, which was the previous video on the channel. And that's that. So you have examples, you can start with an example, etc. So it can be very handy. Just one thing I don't like about it is the fact that you have to refresh manually the browser. Now you can use a CDN. This is the second option. And this option, I like it, and I've used it a lot for my tutorials because it's very easy to set up. So if you don't want to use Node.js and you just want to use basic HTML, CSS, and JavaScript, well, you can use this method. So this method, how it works is that you point to this link, and here you have the version, and then it will load the file. I usually prefer to go to that link and then download the file itself instead of just pasting the link here, but you can do both. And the advantage of this method is that really it's independent from Node, and it will actually work. I think it's more maintainable in a sense. So what I mean here is that if I don't touch the project like in 5 years and I come back, it's going to still work exactly the same. There's nothing to update, etc. Because it freezes, it takes a specific version, etc. and then you use it. But you can also do that with Node.js, but you don't have like the Node thing. You don't have to install Node, etc. So that's the advantage. So here it's using the module type in JavaScript. So it's a JavaScript native modules. So you can do both here, either the old way where you just load the thing here. This time around you need the GS instead of the MGS, and then you use it in another script tag or another JS file that you load through a script tag, or you use this newer way of having a type module which allows you to use import statements. And then finally, it's the npm way with Vite, where you first need to install Vite, and then you use npm install Kaplay, and then you can specify a version by using this notation here. And then here it's a bit more complex to explain how to do it. But if you look at any my web developer as a game portfolio, my portfolio game tutorial, or even I think I used it in the Tori tutorial where Vite is used, but I think you should really refer to the build a developer portfolio as a 2D game tutorial on my channel, which really goes through how to set up Kaplay with, well, Kaboom, but it's the same thing, so with Vite. Alright, so now that we know how to install Kaplay, how do you deploy your games? So this is a question that you might be wondering how to answer. And then depending, of course, on the tool you use, it's going to be different. But for the simplest way, the CDN, is you just zip that file and zip your code base basically, and then put it on itch.io or on GitHub Pages, etc. As long as there is an index.html file, it should be very straightforward. I'm not going to really dive deep into how to do this here. I think because maybe it can change in the future depending on the tools you're using. So if you want, I could write a blog post on it. By the way, I make written tutorials on Substack, which is my newsletter. You can follow, link in the description. So if you want more written content, and the place of written content is that if you want to learn how to do something specific, it's more convenient because you can easily refer back to a text rather than a video. And for more project-based tutorials, this is better as a video because, you know, I can just show you how to build a project from A to Z, and it would take too long to write it out. Now, this video I'm currently recording is the exception because normally this would be in a text format, but because there is a lot of content I want to cover, I would never have the time to write it out. So maybe I will write parts of it in the future as written content. All right. So now that we have covered the various ways you can install Kaplay, etc., let's go to the playground. So the playground is basically an editor that you can use online without having to install anything, just to try out Kaplay. So here you can see that Kaplay is imported by default. You don't see the import statement. That is something specific to this playground. But when you're using VS Code, you'll have to do like Kaplay from Kaplay, etc. So how do you initialize the canvas in a Kaplay project? Well, you call the Kaplay method function, sorry, and then this Kaplay function has various options, and let's dive into those options. So of course I need to increase the font size like that, sorry, so that you can see. I'm assuming maybe you're watching this on mobile, and yep, so here we go. We have a big text, so let's write it out. So here the Kaplay function takes in optionally an object which you can specify a bunch of params. By default, the canvas, when initialized, will take the whole available space. However, if you want to specify a specific width and height, you can do so using the width property. For example, 1280, and the height I'm going to use 720. And if you do that and refresh, well, because I'm zoomed in a lot, if I dezoom, get maybe a with, yeah, if I refresh, so there's a bug with the playground at this size. So yeah, sorry. Can I increase the font size? Anyway, you can see that it takes the appropriate width and height. However, if you want your canvas to be scalable in the sense that it will adapt its size regardless of the window size, etc., you can use the letterbox option, which will make sure that the canvas will scale accordingly, but while retaining the aspect ratio. So you do letterbox true, and it's going to add black bars elsewhere when there's nothing to put. So what I mean is that as long as the aspect ratio is respected, so if it will not expand further, otherwise it would violate the aspect ratio. So this is how you get a scalable canvas that retain an aspect ratio. Now there's also something, the debug option. By default, it is true. It is set to true, and it allows you to open up debug mode by using the F1 key. Now here, I recommend that when you finish your Kaplay project, you set it to false so that you prevent the player, the end user, to be able to access this debug mode, which is done by pressing the F1 key. So here, if can I modify the font zoom in? Okay, and then if I just put the window as it was initially, okay, I'm gonna refresh, and then here, so I just discovered this font zoom in, and then you can you have to do this manually. Yeah, can I have a shortcut? Font recently used editor font zoom in. Okay, I'm just gonna set this up so that I don't have to zoom in the window, the whole thing. So I think it's using the same underlying editor as VS Code. Okay, let's do this more quickly. I think that's fine. All right, now it's very nice. Okay, so you have the width, height, layer box, and debug option. And now the other thing I want to mention is the global property. So by the way, let's first look at debug mode. So if you click on your canvas, press F1. Whoops, I need to first remove this part, which is invalid code. Right to here, press F1, nothing happens. Because I set it to false, so by default it's true. So when you do not specify, it's going to be true. And then you can see the FPS counter, and then you can see hitboxes when you are going to use that. So for now, I'm going to set it to true. But when you finish your project, I really recommend that you do false here. Now the last option I want to talk about is the global option property. And I usually set it to false. What this means is that if you set this to false, Kaplay methods and functions can only be utilized, true, sorry, I want to make it true. By default, it is false. But if you make, no, never mind, sorry, I'm confused myself. It's false because we don't want it to be global. So if it were global, which it is by default, is that you can use Kaplay methods and functions outside of this context. However, if you set global to false, all Kaplay methods and functions must be used through this. So you do k dot the name of the function and the method, etc. Okay, so now that I have covered this, let's show you how to load assets in Kaplay. So loading assets, I think there's an example we can take a look at, and let me just look it up so I don't have to find new assets to show you. Sprite Atlas, Sprite, maybe it's the Sprite example. By the way, use this site, it's very handy. It has a lot of examples you can look at. Okay. Particles, shaders, Sprite, post effect, RPG, bench. Okay. All right, so now we have this. Okay, so okay. That's not what I want now. Here we go. All right, so this is the built-in sprite example, and it really shows you how to load sprites. So here, ignore the Kaplay things. Here you can also set a scaling and a default font, which are other options, but I felt it wasn't very important. The scale is somewhat important, but the rest isn't, because loading a default font, you can just do this elsewhere. You can load the specific font when you need it under a specific text component. Later on, we will be looking at the various components we need. So the most important part here is the load sprite. So here, since Kaplay is used globally and without a context, we can just immediately use the load sprite method. However, if you were to use the setup I've shown you earlier, you would have write const k Kaplay. I would put the global here to being false, and then here I would have to do k dot load, etc. But I will not like redo the the whole thing, the whole example. You know what? Since we have the link here, let's do it so that you really understand everything. So I'm gonna remove all of that and I'm gonna show you. So here we go. So first of all, I'm just gonna paste here the link towards the sprite, so I don't have to look for another sprite sheet. So first of all, let's import. Let's initialize our canvas, and then with a const k, etc. Now if I hit Control S when writing code, it's going to be like this. Now what I'm going to do here is I'm going to set the I'm just going to set the global property to being false, and that's it. So, and then now I'm going to start loading the sprite. So k.load sprite is the usual method you use to load assets. There's also sprite atlas, but I don't think for now I'm just going to present the load sprite function, because the sprite atlas is when you have a sprite sheet with an image with various sprite sheets in the same image, and you want to cut out specific portions and make them their own sprite sheets. So this is what it is useful for. Maybe I'm going to dive into the example that uses sprite atlas later, but for now it's really important to understand how to load the sprite sheets or just basic sprite. So you use this load sprite method, and then the first parameter it takes is the key you want to use. So it's a name that you're going to use in your code to refer to that sprite. Here I'm going to call it dino because it's a dinosaur. And then the second param is the path towards that image in your file system, in your code base. But here we already have something provided by the playground, so I'm going to use that. And then for now, you could use both these two params and call it a day. So now I'm going to create a game object. I'm going to talk about more what game objects are in Kaboom later on. But I'm going to just, actually I don't even need to assign it to a constant, but just to keep it simple, to create a game object in Kaplay, you use the add method, and then you pass in an array of components. Those components are provided mostly by Kaplay, but you can create your own custom components. So one of the offered components is the sprite component, and you pass in as the param the name of the sprite you want to display. Now if I hit Control Save, you can see the whole sprite sheet has been displayed here. By default, when you create a game object that isn't in a position, you don't specify the positional component, it's going to put it at the top left corner. Now here it's where it's handy to maybe have the scale property here and scale it 4 times so that you can see it better. So this is the whole sprite sheet. Now how would you go about setting specific animations? So here you have an optional third param for the load sprite method, where you can specify the slice x property and the slice y property. The slice x property, basically you tell it how many frames there are in the x-axis horizontally. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 frames, so I'm going to have 9 here. And then slice y is going to be 1, because there's only one frame per row, I guess, per column. So here we go. By default, it's going to take the first part and cut out the rest. Now, how do you define an animation? Well, you can have the anims property, and then here you choose on name. So here I'm just going to do the run animation. I'm going to call it run, and it's another object. And then you specify the from key, which is the initial frame. It's going to be frame 0 to the last frame, which is going to be frame index 8, because in Kaplay, okay, wait a minute, why is it highlighted this way? From to, okay. So one thing I need to mention is that here, frames are computed, have a number on a sprite sheet that always starts with 0, so it's 0 indexed. So here 0 to 8 is actually 9 frames. So now what I'm going to do is, now that you have this, you can in the sprite component pass a second param and specify an animation, and you use the run animation name. And then you can see here. Now here by default, the animation will only play once and then stop. You can use the speed property, not the speed, sorry, the loop property to define if it runs only once or it loops infinitely. So now it loops infinitely. Now there's something wrong with the animation. It doesn't look that good. So what I'm going to do here is I'm going to do this. I'm going to comment that out. I'm going to comment that out as well. So we have jumping, landing, jumping, and then like that. So it's a strange animation. I don't see where's the beginning and the end. So is this only one animation? I think it is. Okay, never mind. Animation is fine. It's just a dinosaur that will jump and then jump again, I guess. Anyway, so I'm gonna put it back, and then I'm looping it, but this animation clearly doesn't seem it is designed to be looped. But anyway, you can also increase the frame rate. Here I'm gonna have a 10 speed of 10, and then for example the higher you go, for example 60, it's very fast, 3 frames per second, very slow, etc. So yeah, so feel free to configure that as you see fit. So this is how you load sprites in Kaplay, how you load assets more generally. There are other methods to load assets. So for fonts, if I go to the font example, is there one? Text maybe. You can see that you can load a font by passing in the key you want to use and then the path to it. And that's it. And then there's 2 types of font. There's the bitmap font as well, which you can load, which is an image of characters. And then you specify the width and height of each of those characters. So those are your options when it comes to fonts. Now, so except for images, etc., images and text, and there's also audio that you want to learn how to load. You can use the load sound method, and then here the same structure, the name you want to use, the key, then the path towards the sound itself, and then you can also here, that's it for loading. For playing though, you use the play function, the Kaplay function. This, you shouldn't confuse this with the play method later on I'm gonna see for playing the animation. So one thing I should have shown in the sprite example is that you can specify the animation by default in the second param of the sprite component, but you can also call a play method on your game object. So maybe later on I'm going to show an example. So for playing the sound, you pass in the name, the key, and then as the second param, you have your options you can pass as well. Optionally, you can decide whether to loop or if it's paused, and even the volume. You can set the volume, or you can adjust the global volume by using the volume method in Kaplay. All right, so now let's look at let's write our own code. So I'm just going to take the shortest example possible here and just redo everything. So const k Kaplay, and then your global false. All right. So now one other thing I want to talk about is how scenes work in Kaplay. So now you know how to load fonts. Now it's time to look at how to manage scenes. So by default, what you see on the canvas is the default scene. However, you can specify specific scenes. So the way you do that is by using the scene method in Kaplay. It takes as the first param the name you want to use. This is a pattern that you see often, where for a lot of those things like load sprite, load font, load bitmap font, load sound, etc., you have the first param, which is always the name you want to use for that specific thing you're creating, and then the second param is the path. But for here, for creating a scene, the first param is the name you want to use. Let's call it test scene. And then the second param is going to be a function. Here it's preferable to use an arrow function because it's more compact. And the code within that function here is going to be the logic for that scene. So here, one thing I want to showcase is that in Kaplay there is default sprites you can use, and one of them, I think it's the only one available, can be accessed by calling the loadBean method. And then you have access to, let me create a game object here, k.sprite, adding my first component here. And then here, I'm going to call it bean. Well, by default, when you use the loadBean method, its name is going to be bean. So now if I refresh this, we aren't in that scene yet, so that's why nothing appears on the screen. Here in the Kaplay initializer, I'm going to also make the scale 4 times so things are clearly visible. And then here, to go to a specific scene, you do k.go and then the name of the scene. And here you can see the bean character. So now if you add another scene, k.scene, so test2, and then you could have another here, and then here I could use the add method, and then add this time around a text component and hello world. So now here, instead of going to test2, I'm going to go to test1. So what you can do, for example, is that we first go to the test scene, then we, by using the wait method in Kaplay, we can just wait 3 seconds and then go to call the following function, k.go with test2. So now if I put test here, fresh, so 1, 2, and 3 seconds, and then it goes to the other scene. So here's how it works. So this is how scenes work in Kaplay. Now let's look at how game objects work in Kaplay. So game objects are, I would say, the core concept of Kaplay. So everything is a game object. A game object is created, as I mentioned earlier on, by using the add function, add method. And usually the way you do it is, for example, I create a player, a game object, and I use the k.add, and then it takes an array of components that is going to determine the various behaviors and attributes of that game object. And those components, later on, we're going to I'm going to talk about the major components that you're going to need when you're making a game. There are many of them, but I'm going to talk about a very specific subset. So here, you use the add function and pass in an array of components. And then here, for example, I'm going to create a player. The way the components I usually use for the player is, first is the positional component. So I specify a position on the canvas. So let's say 100 by 100. I usually do this last, but I always first start with the sprite. And if there is no sprite, you can use the rectangle component, which is just going to draw a rectangle, which is going to act as our base, our placeholder graphics, I guess. And then here, I also can use the area component, which creates automatically a hitbox for our player. You can configure it later on. So when I'm going to talk about the major components in Kaplay, I'm going to do that. And then here, so rectangle, etc. So if I just do this, you can see a rectangle appearing here. And if you press F1, you can see the hitbox here. So this is how you create a game object. Optionally, also, you have another option. Instead of just adding it directly to the scene, what you can do is use the make function. So make, what it does, it will create the game object but not put it on the scene. So you have to later on in your code do a k.add yourself and then pass in the player reference, and then it's going to add it. This is useful in certain cases where you want to create make constructor functions that will make the entity for you and then later on add it to the various scenes you want. So I prefer to use add most of the time though. And then after you create the add, after using the add function, it returns a reference to the game object that can store in a variable or a constant. And then one thing I want to showcase is that you can not only pass just components, but you can also pass objects, which you can use to add custom properties to the game object. So by default, if I do this and I just console.log the player, we're going to be able to see the shape of a Well, actually, where are console.log supposed to appear in the playground? So yeah, so maybe like if you use this, console.log instead of log. So now it should appear in the console. Yeah, you can see. So here I'm just gonna increase the font size so you can clearly see. So here it's an object, and then you have the various methods available. So you can see that there is the add method in the player because you can add children to game objects. So you can do player.add and then create another game object as a child. And then you have a bunch of properties and stuff like that that are default, basically, provided by Kaplay. For example, the width or the position, screen position. You can access the position property. For example, if I want to know what is the position of the player currently, I can just do player.pause and it will appear. You can see here. X 100, Y 100. Okay, so now that you have a basic understanding of what a game object is and how to create one, let's actually give you an example of a child game object. So if I want to create a child game object, what I'm going to do is I'm going to take, for example, the player and use the add method again. This add method this time around is from the game object and not the global one, the one from Kaplay. But they work the same way. So I can create another rectangle game object, 10 by 10. However, the position, for example, I can also specify the area if I want. And then here, the position, what is special here is that the position is relative to the parent. So if I do 0, 0, it's going to appear on the parent. By the way, I'm just going to change the color. You can do so by using the color component. And you can use that, specify RGB values, but you can also specify hexadecimal values by using the color from hex and then passing in the hexadecimal code. But here, just to keep it simple, I'm just going to do it 0, 0, 0, so it should be black. And you can see it's on top of the parent game object. Now, if I offset this by 10, you can see it going to move to the side, 20, etc. But it's relative to the parent, which is very useful. And so the cases where you want, for example, let's say you have a player with a weapon that turns around them and follows them. So you implement this way. All right, so now it's time to introduce the major components. So the sprite component was the main one I wanted to talk about, the first one actually. So let's say I have my player, and then I have my bean. So I'm just gonna load the bean here, load the bean, and then here I'm gonna do k.add, and then here I'm gonna use the sprite bean here. As I explained, it's a default sprite available in Kaplay, so that's why I'm using it, so I don't have to search online for a sprite sheet. There's also the sprite sheet I've used in the Dino example, which is available in the playground, so you can use that as well. So here I use the sprite bean, and then, well, actually, I'm gonna need an animation, otherwise it's not gonna work. So I'm gonna just copy this and paste it just so I can have two instances of the playground where I can see the code. So in the sprite, just need the path here. Then if I go back here, I'm gonna just load the assets properly. So load sprite, dino, then the path, and then we said slice x is 9. There's 9 frames, sorry. Slice y is 1 because we have 1 frame per column. And then the animation, we only had 1, so anims, and then here I'm going to specify the run animation. By the way, as long as you have single word add properties, you can just use, you don't have to use quotation marks. And then from 0 to 8, and then let's loop the animation. So by the way, something I probably forgot to mention, I'm just gonna use dino here, is if I just put that in here. So this is frame 0, 1, 2, 3, 4, 5, 6, 7, and 8. So it starts from 0. Just wanted to show it visually so you don't get confused. Oops. Okay, so now let's say we have our sprite, player sprite here. Let's add an area to it, a positional component as well. Let's put it at 100 by 100. So the first param is the x coordinate, the second param is the y coordinate. Sorry if I didn't mention this earlier on. So here we have our sprite. If I press F1, you can see that the hitbox is slightly taller than the sprite itself. And this is where you're going to need to tweak it yourself. So let's talk about the area component as well. So the area component, you can change its shape by passing in an object and then specifying the shape property. And you need to use the rect constructor. So you can use new.k.rect. This is from Kaplay. And this is going to specify a rectangular hitbox. The first param is going to be a vector2. So this is another concept that I need to talk about. But usually vector2 in Kaplay is just an x and y value. It's just a data structure that holds an x and a y value. So here you can create a vector2 like this by just calling the component itself. And then here I'm just going to put it at 0, 0 because this first param of the rectangle is just going to position offset relative to the game object. I don't want it to be offsetted. I just want the position to be the same. That's why I put a 0 here. So it's going to be 0, 0. It's not going to change. It's not going to be different from the original 100 by 100 position of the game object, the player game object. And then the second param here is going to be the width and the height of the hitbox. So the width is going to be, let's start with 16 by 16. And then if I press F1, you can see that it's a bit taller. That's why here you can actually decide to offset this by 16 and it's going to drop down. So 16 is too much. By the way, in game development, the farther you go down, the higher the value of y. So the farther you go down. It might not be intuitive, but yeah, that's how it works. So here we have our hitbox that is relatively well positioned. You can decide whether or not to reduce the width maybe to 12 and then push the hitbox forward by 2 or maybe 3 or 4. Let's start with 4. 4 is too much, so let's start with 3. So this tweaking game is what you need to do to really set your hitbox correctly. Alright, so you have your hitbox, you have the player, okay, everything is fine. And now, just to show you, you can play animations by doing player.play and then specify the animation name. You could have done this in the second param here as the default animation, but just to show you if you have multiple animations, you can switch between them by using this. So play, and then the name of the animation. So the animation is going to be a dino. No, that's the sprite, sorry, the run animation, sorry. And then you have the animation play. Alright, so that's how you use the area component and the sprite component. Now there's also the body component, and the body component is used to have collisions. So while the area component creates a hitbox, it will only make sure like you can check like overlap between your game object and other game objects using the onCollide methods, but you can use the body component to make it solid or affected by gravity. So using the same example, let's add a platform right below. So I'm going to create a game object under, which is going to be the platform. I'm going to use a rectangle. I'm going to set it to be 1000 of width, maybe 1000 by 50. I'm going to use the area component. It's going to perfectly fit the rectangle, so I don't need to specify a custom shape. As for the position, I'm going to set it to 0 as the x, and here maybe 400 as the y. Maybe it's too much, so 300, 100 is too okay, too much, 150, Okay, so we have our platform here. Additionally, if you use the area component, you can use the so if you use the rect component and the area component together, you can use the outline component and then specify an outline. So with a boldness of 3, for example. Now, there's a lot of things like that happen in Kaplay where you cannot use certain components if other components are not added to the component array here. So you're going to have an error message that is going to tell you what is wrong, so you can easily fix it. So now here in our player, so here I did not assign it to a constant because I don't need it. It's just a throwaway platform game object. So here, let's say I add the body component. So by adding the body component, it's going to be affected by gravity, but you can see that nothing happens. That's because you need to set the gravity. And by the way, in the scene example I've shown earlier, you would write all this logic, not the asset loading logic, but for example, this logic inside of its own scene. So let's do that just to be like clean. So I'm going to define a scene. I'm going to call it game. You can define it however you'd like. I'm going to pass in this as a second parameter function. And then here, I'm just going to include everything we have here inside. So now, and then finally, don't forget to go to that scene from the main context, from the root. So game. So basically this does the same thing. I just wanted to make things clear. So maybe I have to reformat this code. Oh no, that was a mistake. Here we go. Okay, so now for the gravity, you usually need to set it. You cannot set it. There are certain things that you have to reset from within the scene. So if I try to set the gravity using the setGravity method offered by Kaplay and set, for example, to 1000, it actually works. Okay, so it works. So you can set the gravity outside of the scene. So that's good. So if you want to have a global gravity that is in this all levels, you can do that once and then define your code. So usually this function you might need to, if you want to organize your code later on, you would create a separate file and then import that function and then pass it here as a second param, for example. So now you can see that our player just passed through the platform. That's because we need to also add the body component to the platform itself. However, this is where a new concept is going to occur, is that you see both were affected by gravity. But if you want to use platforms, etc., you need to specify a param from within the body component. And here, this param is called isStatic, and you need to set it to true. So here, you can see that our dinosaur is on the platform. So by default, the body, just adding the body component and specifying a gravity will make the game object dynamic or affected by gravity, so it will fall. But you can specify an option called isStatic from within the body component, and this is going to make sure that the game object is going to remain unfazed by gravity and is going to act as a wall, basically, or a platform in that case. All right, so that's it. And then let's look at, so I've already talked about major components like the color component to change color, the outline components. I've also mentioned the rectangular component, the text component. You have seen me use it. Yeah, let's dive into the text component a bit more. So here is an example that I used like global Kaplay, so without having global false, etc. One thing I want to mention is that after you have loaded your font, here is the basic usage. So I'm just going to try to just going to take this, copy this, create a new example. I should have not done that, actually. I realized. Can I go back? No, I cannot. Okay, let's go back to rewriting our example. Const K, instead of using the second tab I had open to just pick the things I needed, I just lost my progress. So here, global false. And then here, I'm just going to paste the statement I had here. I'm just going to add a K in front of it. So I'm going to load the flower sketches font. Flower sketches.ttf. That's the full path. And then here, just to show you how to use it, I'm going to create a game object and use the text component. So you need to create a game object to be able to use the text component. You cannot just call k.text, because you need to also specify the position of that text, for example. By default, if you don't specify it, it's going to be at the top left corner. But here, let's put it at the center. This is how we can do with the center component. It's something new. Here it's undefined for now because nothing like we haven't specified a text here. So here you specify the content of your text as the first param. I'm just going to modify this. Modify this to be clearly visible, more like pretty, I guess. Usually my code editor takes care of doing this, but since I'm teaching this whole crash course on the playground, so I have to do it manually. So here, let's type in hello world as our default text. If I do this, you can see that you have our hello world at the center, but you can see that it is the origin of the text is going to be at the top left corner. By default, game objects have their origin at the top left corner. What if you want the origin to be at the center so that the hello world position is actually going to be centered? The text is going to be centered. This is where the anchor component is going to come into play. So here, you need to use the anchor component. You need to specify an area component beforehand. So here by default, it's just going to make a hitbox around our text. And then right below, you can actually the order of the components you put them in the array is not important. You can put them in any order. It's just that usually I prefer, like, I use the text component, then the array component. I usually put them in the order of usage, but you're free to place them however you like. All right, so now what I wanted to do is we have the area. Okay, now I can call the anchor component, and then you can specify the anchor to being center. And this way, the origin is going to be at the center. Now our text is centered. You can have top left, top right, but you can also use a vector too. So by calling vector 2, you can specify a specific position. Maybe that maybe was an old behavior. I don't think it works here. So forget that. But here you go. So hello world, etc. Now that we have hello world, what I wanted to do is to show you how to change the font. So you can do, as we saw in the example, have a default font here, but I don't prefer to do this. I prefer to change the font per text component. So here, as a second param, you can pass an object and then specify the font name by passing the font property and putting the exact same key here we use to load our sprite. So here's the font. It's a flowery font. You can also increase the font size by adding the size, I think, 32, maybe 64. Yeah, it's 96. Hello world. So that's the font. All right, maybe the background. By default, you can set the background being like black. Here you go. You can do this, but usually I prefer to create a game object that takes the whole screen and then just change the rectangle's color. That rectangle. So this game object rectangle is going to take the whole screen, because if you use the set background method offered by Kaplay, it's going to color everything. And if you use the letterbox scaling I mentioned earlier, you will no longer have the black bars. It's just going to be the same color, even though. So it's going to look very weird where your sprite character, for example, will move off screen, but it's going to seem that as if like the background is the same, so the screen should continue, but it won't. So that's why I prefer to just create a rectangle, a game object that uses a rectangle, and the size of the rectangle is the whole width and height of the canvas. All right, so one thing I want to also mention, and I forgot to do it, is I told you earlier on that you don't need to only add components. So you don't need to only add components to the array of here. You can also add an object which can store custom properties you want to define. So think of it as if you were using object-oriented programming and you had your various properties, attributes. You can define them here. So for example, you could have the HP or your name, etc. And then you pass in the values you want. And then later on, you can access those properties by just storing that game object. So let's say I store it in like my text, I guess I'm going to call it. Then you can have like a second text or second text. And then here, hello world again. And then here, right below, I can do my text and then access the current text by doing dot text and then replace that with the new text with the second text, and I can access that by using my text and then the name of the property I have defined here. So second text. This is, and you can see hello world again. This is pretty powerful because this allows you to bypass the need to use classes and while still having code that looks clean. Looks understandable and easy to read and modify. All right, so one thing I want to mention again is that here, the center component, you can use it to have the center of the canvas. The positional component either takes two values like that or takes a vector 2. So vector 2 is something that comes up a lot. So here you can do the same 100 by 100. So that's the data structure. There's no reason to do it this way instead of just passing 100 by 100. So you should do that whenever possible. All right, so yeah, but k.center, if you look at the return value, maybe not in this editor, you're going to see it returns a vector 2. All right. Okay, so now I want to talk about tags as well. So this is going to come handy in collision detection. So I'm going to talk about this component later on. So here, the next thing I want to teach is how to, when you create game objects, how to get them, how to like basically query them. So let's say I create a bunch of game objects. Actually, the tags is going to come in handy right now. So let's say I create game objects. Let's say I create 3 game objects. They're empty for now. And let's say they're all rectangles of 10 by 10. So they're all 10 by 10 squares. So here we go. Maybe the formatting is not good, but it doesn't matter. And for each of them, I'm going to give them a tag. So not only can you add objects in that area of components, but you can also add a string which is going to act as an identifier for that game object. So here, let's say I'm going to create a tag called square, and I'm going to assign it to all the game objects I created here. Square, square, square. So we have our square here. They're all in the same position. It's very small, so maybe let's scale the canvas 4 times so it's clearly visible. It doesn't help much, but it's not that important. Maybe let's offset them. Okay, no, I haven't specified the position, so that's why. So the position component here, let's keep it at 0, 0. By the way, if you want a 0, 0 position, you don't need to specify the positional component, but let's do it just to be like clear. And then let's copy that over. Whoops. So let's copy that over to the other stuff. Here we go. And then here we go. So here, let's offset this by 50 and then here by 100. So now we have our 3 squares here. This is where the tags come in handy. There's this, I'm going to store my squares and use the get method offered by Kaplay to query, fetch all the game objects that have the square tag added to them. So the way you do this, you do it square, you pass in the tag, and it's going to return an array. So if I use k.debug.log, this is another way of logging things. And then just pass in the square. When you can see object, 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 and object, object. You have your 3 objects. So the k.debug.log is when you want to display things on the canvas itself. you would use console.log if you want to just display it in the console. Here. So we have an array, 3 of them, and each of the objects we have them. Now, one nuance I want to talk about the get method here is, what if you had a game object that is a child of another game object? So let's say I add this first game object is the parent of that second game object. So now if I look at the result by pressing F12, you can see that we only have 2 game objects, no longer 3. If you want to get all game objects, regardless of if there are children of other game objects, you need to pass the second param as an object and specify the recursive property to being true. If you do so, what will happen is if I press F12, you'll have your array with all your 3 objects. What happens if you want to use a component after the fact, after having created your game object? So let's remove all of this. And let's say we have our square here as a single game object. Let's increase between a 100 by 100 just so things are clearly visible. And after having created the game object, later on in my code base, I want to dynamically add a new component. Let's say I want to change its color after the fact. For example, if the player clicks on it. We're going to later on see how to handle input, where we're going to see like how to make things like clicking, moving around, pressing keys, etc. But for now, if you have your square here, you can use the use function, use method to add a new component. So here I'm going to add the k.color component that we looked at earlier on, and I'm going to put it at a color RGB of 2 red. So this should be red. So now it will use that component after the fact. There's also the square.unuse, and then you can pass in the name of the color, the component you use, and it's going to unuse that component. So let's say I'm going to use the wait, something offered by Kaboom, instead of having to use set timer or forgot the name. Anyway, Kaplay offers their own timers, so you can just use this like that. So what will happen is we'll wait 3 seconds before unusing the color component, and that means the rectangle will go back to its original shape. Here we go. All right. So the first param is the number of seconds to wait, and then the second param is the function to run when the timer is over. And there's also an asynchronous form of that function where you use await, and then you just have one param, and then you would call this later on under. So I'm not gonna go over this. You can see in my tutorials. By the way, all my Kaboom tutorials are applicable to Kaplay, so you can follow them. Just do the initial setup differently. Install Kaplay instead of Kaboom. So now let's look at how to handle collisions. So, to handle collisions, the way I'm gonna do it is I'm gonna also introduce the move component, which is something I didn't do. So let's dive into that. So let's say we have still our square. Let's reduce the size to being 50 by 50. And now this square, I'm gonna remove that. It's no longer needed. And I'm gonna add in area component to it. So it's going to have a default hitbox. Remember, you can access the hitbox, the debug mode by pressing the F1 key. I think the debug mode is one of the most powerful and useful things that Kaplay offers that I don't see in other libraries for making games. You don't see as handy debug mode, I would say. So now that we have this and that, let's write our logic. So what we're going to do is we're going to create a second game object. I'm going to call it target. And it's going to be a small rectangle, 20 by 20. And we're going to place it. So I'm going to also specify the area. And I'm also going to place it at a position of 30 by 0. So maybe not 30, more than that. 130 maybe. All right, so we have our second square here. So yeah, now that we have that, what I'm gonna do is write our first collision logic. So how do you do collision detection in Kaplay. There are many methods you can use, but the most important one is the onCollide method and the onCollideEnd method. So onCollideEnd is a method that is attached to the game object. So let's say I want to check if the target has collided, so you do onCollide with, and then the first param of that function is the tag of the game object you want to check collisions with. So here, target onCollide with the square tag. So you can see that you only need a tag for the second game object you want to check collisions with. And then the second param is going to be the function that is going to run when the collision happens. Here I'm just going to debug log collision happened, a message that says that. So here nothing happens because the square doesn't move and we need to move it. So the way to move a square is you can use the move component. So I'm going to maybe have an example when we're going to use input detection. So I'm going to talk about how to handle input. I mean, move things around using the arrow keys. And in that, the move component is really used a lot. So you do k.move, and this is the first form of it. And then you can move, I actually don't remember the, what's the particle? Let's try it out, and then if there's an issue. So 100 by 0. Maybe the second param is the speed, I think. All right. So if I put it here, okay, the second param is the speed. The first param, I think it's a vector 2. And let's say, yeah. So here vector 2 comes in handy. So the first param of the move component here is the direction in which you want the collision to the game object to move towards. And then the second param is the speed. So here we're at the speed of 10. I could increase that to 50. And then you can see when it collides, you see the message collision happen at the bottom of the screen. So yeah, the reason it's overlapping is because we haven't used the body components. So if we were to use the body component for both of them, so let's say I add the body component here, and I also add the body component to the target, they're going to push each other, I think. Yep, you can see that. All right, so the other form of the onCollide is you can use the onCollide from Kaplay directly, but you need to specify the tag of the first game object you want to check collisions with, and then the second one as well, before passing in the function. I rarely use this form because it's often just more convenient to use that. So here we go. So the other one is target onCollideEnd, and it will run when the collision ends, and it can be useful when you want to, for example, finish an attack. For example, yeah, it's useful, for example, when you want to finish an attack. Your player finishes an attack, and then how do you say, put back their swords or something. So here I'm just gonna put a debug log message as well, collision ended. And then here, it's never going to happen because the objects are pushing each other because of the body components. But if I remove, for example, for the target, I remove it, you can see collision happened and then collision ended. I did a typo here. All right, so that's that. Now you have an idea how to handle collisions, etc., etc. Now, how do you handle user input? So onKeyDown, onKeyPress, onKeyRelease. And you can even have like controller support and etc. I'm not going to dive into controller support. By the way, really this tutorial is meant as like a starting point, but afterwards you can check the documentation. And by the way, if the documentation is still not complete, you can still refer to the original Kaboom.js documentation. So if I go to Kaboom.js, oops, I did a typo here again. So if I go to Kaboom.js, you can search it. And by the way, a trick here is that it's more efficient to search. Don't use this. It's not that effective. You do Control F, and then you search what you need. For example, button, and then you'll get, using the buttons here, you can see like the documentation. It's a much more comprehensive search. It's a better search than this because certain things don't surface when you use the search bar here. So I recommend still using the Kaboom.js documentation if there's something missing out in the Kaplay documentation, because it's not yet finished, but it's mostly like the same thing. So yeah. So now let's see how to handle user input. I'm going to cover the basic version of it. And now Kaplay has a new system for inputs, which allows you to specify buttons for both multiple different buttons for the keyboard, for the controller, and for the mouse, all at the same time. Because this feature is in alpha, I will not cover it in this video. So I'm going to wait for Kaplay to release its 3001 version. By the way, Kaplay, the way it works is that it works in thousands. So there were, when it was Kaboom 2000, and then Kaboom 3000, and now it's Kaboom, the version here, I think it's still 3000.1.17, and then it's the development for version 3001 is active and is currently ongoing. All right, so now let's load the bean. I'm going to use it as the placeholder asset, and I'm going to create our player and create the game object for it, and then here I'm going to use that as the sprite, the bean sprite. Now I'm gonna maybe scale it twice instead. All right, now here I'm gonna remove the black background just to make things more visible, and then I'm going to add the, I think that's it. So yeah, so just to handle positions, so to handle input, it is preferable to use the onKeyDown, onKeyPress, onKeyRelease methods directly from the player, so the game object. So the game object offers those methods, but you can also use the global version of those game objects. Now the reason why, I'm not actually sure. So if I go to the documentation, there is a guide. So if in the guide section you have the so installation, basic concepts, data between scenes, etc., debug mode. So data between scenes, you maybe should give that a read. I haven't covered it. It's very simple, so I might cover it later on, but in case I forget. Input binding, which is the new, I think this is a new feature, etc. Then shaders, which is something that I'm not going to cover in this tutorial, but it's very handy to make your games look good. But one thing I'm going to talk about is the optimizations. So here they recommend that you avoid the global names, use the game object local input handlers. Similar to above, it's often better to use local input handlers as opposed to global ones. One thing though is that it's not explained why it's better. It's just mentioned that it is. So there's probably a reason, but I don't know why. And if you're a maintainer of the Kaplay library, please tell us why. And I might ask this in the Discord. By the way, it's a bit too late to promote this, but the Discord server there's a Discord server for Kaplay, and the link is going to be in the description and in the comments. I recommend that you join it because it's where you can ask questions, see questions that were asked by other people in the past, and really it's the most efficient way to get help, I would say. Let's go back to our example. So here I'm going to call player.onKeyDown, and then the onKeyDown method in Kaplay has multiple forms. There are two main forms, I would say. It's either you specify as the first param the key you want to listen on, or you just specify directly the function that is going to run when any key is down, and it's going to take care of passing to the first param of your function that you pass to the onKeyDown the key itself. This is something I prefer to use mostly, to have the specific, but to have the specific, to have this form instead of the other one where you specify a specific key, so that you don't have to call onKeyDown multiple times. So, but there might be some cases where it's preferable maybe to use the first form. So in this tutorial, I'm just going to use the second one. So here, if you do, for example, if you console debug log, k.debug.log, and then log the key, you can see that as I press, you can have space, up, down, left, right, etc. So as I said, I'm not going to dwell much on this input system because there's a new one that is an expansion on that, and it's going to probably be more used for professional games because you want to be able to specify multiple inputs things at once, multiple different keys, etc. And onKeyDown, etc. doesn't allow you to do that. So just to remind you, it's just go to input bindings. This is offered in the newest version here. So you have bindings, you specify an action, then you can specify various keys for the keyboard, various for the gamepad, and even for the mouse. But as I said, it's still in development. Okay, so on KeyDown, you have the key here. And what I'm going to do is I'm going to have a simple if statement. If the key is equal to, let's say, the right key, then I'm going to take my player and I'm going to use the move method. So you can use the move method. Not only there was a move component where you can just specify immediate movement that happens as soon as the game object is created, but you can use the move method to actually move the player in a certain direction. Now, in conjunction with that, you can, as I said, pass an object in your array of components to specify custom properties. And this is where I'd like to create a speed property and specify a value. And then here I can refer to it by doing player.speed. And then you can specify as the first param the speed that is going to navigate, that the player is going to navigate on the x-axis, and then 0 on the y-axis because we just want to move horizontally. So if I press the right arrow key, maybe I got it wrong. Probably that's because I'm missing a component. Player move is not a function, so this method is only available if you use the body component, and you can only use the body component if you use the area component. So we need to add both of them here. This move is not a function. Really? What's the issue? Let me refresh here. Okay, this move is not a function. Player.move. Okay. Well, it should be. What am I doing wrong? This used to work. So you probably need to specify the positional component as well, and you need to add your commas, so be careful with that. And if I press, here we go. So the positional component is mandatory even if you're not going to specify a position. So it's going to put it at the top left corner, but if you don't use the positional component, you can't modify the position after the fact, because remember, to access the position, once you use the position component, you can use player.pause. But if you don't use the positional component at all, even if you want to, like, you don't even leave it empty, then player.pause is not going to work. So that means under the hood, it's not going to be let you move the player. So here I press to the right and I can move to the right. So that's cool. By the way, I just wanted to showcase a new blog post I've written on how to fix diagonal movement in 2D top-down games, because in 2D top-down games, if you implement using a naive approach, what happens is that you're going to move faster diagonally than on each side. So you're going to move faster diagonally than if you were to move only to the right, for example. So here I've written a blog post on how to fix this. I'm not going to dive into it, so feel free to check my Substack. The link is also in the description and hopefully in the pinned comment as well. So here we go. So this is how you do like onKeyDown. Same thing with onKeyPress. Really works the same way. The only difference is that onKeyPress, which is written like that, it's just going to run once immediately, and then yep. So you will only like jitter like that. So it's useful for attacks, etc. And yeah, so onKeyDown, onKeyPress, and there's also onKeyRelease. So for example, if you want to only move to the right when the right key is released, it's going to do that. So it's a strange behavior, but I just want to show you how to use those methods. All right, so that's that. And then for animations, as I've shown you here in this example, you don't have any, but you use the play method on your player. So imagine that the bean had an animation, so you would play and then play that animation. But for example, you would have another input handler, for example, player onKeyRelease, which for example would set back the animation to default, to the default animation. So you would do like player.stop, or to stop the animation, or change it with another animation by play and instead idle, for example. So this is how you would go about it. One thing I want to mention, of course, is that it's wise to always check beforehand what the current animation is playing, and you can do this by having player.curAnim, and it's going to give you the name of the current animation. And then you can check it. As long as it's not equal to the animation you want to actually play right now, then you can play that animation. The reason you do this is because you don't want to interrupt an animation mid-play. So let's say my idle animation is already playing and it is at frame 3. You don't want to restart the animation again. You don't want that. All right, so that's that. And yep, now I've already covered how to play sounds. And going forward, there is a couple of things, more advanced features. I would say you should better like watch my project-based tutorials or just look at the examples here. So one of them is the tween feature. So let me just find it. So tween is very handy. It allows you to have like transitions like that. So like that, and then ease out those various transitions. They're very useful. So here's an example on how to use them. There's also mouse press and on-click handlers I forgot to mention. On-click is just as onKeyDown, onKeyPress, just you use on-click. So not much to say. For example, here, if I click on the player, you probably need the area component for this. On-click, let's say it's going to do k.debug.log, and then let's say test. So as every time I click on the game object, it's going to do this. So yeah. You can also use the global k.onClick as well, but as I said, it seems to be more performant to use the methods offered by the game object itself. All right, so let's go back to tween. So here I recommend like looking at the example. So the tween this is a tween. So this thing here is a tween. It has 1, 2, 3, 4. So maybe I should increase the font here. So what I'm going to do is I'm going to press F1 and then zoom in. And I do this again. So just ignore all this clutter and look at this part. This is the actual very important part. So the first param is the start value. The second, so the current position of the bean, the initial position of the bean. Then you have the destination value. You want the final value to be the mouse position. So mouse pause is a Kaplay method you can use to get the current mouse position. So you do k if you're not using global Kaplay, you do .k. So yeah, and then the duration is in seconds. So you specify a value, let's say 3 seconds. The transition between the original position and the final value you want. And then the value, this is how the value should be updated. This is where you actually write the function that is going to change the value gradually. So here we modify the position of the bean as the value change here. And then the interpolation function, there are many easing types, and the way you access them, you can do this like that. So here, k.easings, so if you're using non-global Kaboom, and then you have linear, you have a bunch of them. They're all documented in the documentation. So that's here. If I do tween, maybe not the reference doc, I think that's the, if I do tween, you can have the tween in math section, and then you can see here tween controller, not here. It's not, you can have easing out quad. You can see that it's not very convenient here. If you look at the Kaboom.js documentation though, let's say I'm gonna remove that. Kaboom.js documentation, and then type in here using Control F the tween. You can go here, and you can see that here in the easing function, you can see like tween controller. Okay, it's not here. Easings, it's the easings thing. Easing, and then you have the name of all the easing functions you can use. So maybe here as well in the documentation, you could have here, if I type in easings, you would have it. Okay, so but you wouldn't have all the name for them. So yeah, for now it's a work in progress, the documentations for Kaplay. So feel free to use the Kaboom.js documentation, which are more complete for now. All right, so this is how you use a tween. And yep, so it's a nice feature to transition things. And yep, the other things for levels, so for making your map and layout, there is the add level method that allows you to create levels using arrays of strings. Maybe there's an example here, the level example. You can see how it's used. You use these symbols, and then for each symbol you specify a game object. I personally never use this. I never use it because it's not performant, but I do recognize that it is handy. I used it in a tutorial, and my JavaScript platformer tutorial. This was before I figured out how to use tiled. So here again, my Substack is very useful here because I've written a whole post on how to use tiled with Kaboom.js. It's the exact same logic for Kaplay, where you can use tiled, which is an external program where you can draw your levels, and then you can import that into your as a JSON file, and then import that into your game. And here I show the code and explain it. So hope you, yeah, this, I'm gonna just link the general JS Legend dev Substack here, and then you can go and search for those posts. All right, maybe I'm gonna put the link for each thing though, so maybe, yeah, just to be more convenient. We have covered the most important parts. For the shaders, I just want to give you a taste. Just look at the examples. You can change the color, etc. There are more interesting examples in the playground. I don't know if they're here though. Ghost hunting, what is that? Oh, there are new examples, so that's nice. So yeah, feel free to check these examples. There's a lot of pretty cool things you can take inspiration from for your games. So for example, this uses shaders, and this is very impressive, very nice. So if you do up and down, you can have various different effects, even like the light, etc. So that's nice. So yeah, I'm not very familiar with shaders. I don't know the shaderland GLSL. I haven't learned shaders. That's why I didn't want to cover it, but I know how to use them, how to load them in a Kaplay, for example. So maybe I'm gonna dive in and read the book of shaders, which is the recommended material usually shown to beginners for this. Maybe not beginners, but people wanting to learn on the subject. All right, so now the last thing is to, yeah, there's two things. One is the state machines, so how to program an AI, enemy AI, etc. I think it's going to be too involved to code in this tutorial, and maybe there's an example here. The code here is, it uses onStateEnter. So to use a state machine, what is a state machine? It's a way to program an AI. You specify various states. So here, idle, attack, and move. And then you specify the default state. And then here, what happens is that you enter into the default state, and then you have a handler for your states. For example, when the enemy enters the idle state, you will run some logic and then move on to another state. And this is how AI is done. So for example, this ghost, first it is in the move state, it starts moving, and then at one point it's going to remain idle. And then after having remained idled, it's going to move on to an attack state. So really I recommend just looking up this code. In my Metroidvania tutorial, I have written the code. I did the AI for enemies and etc. So this is something a bit too involved for me to do here. Here's the most basic example that is going to give you a taste of what it's like to code an enemy AI. So yeah, I recommend diving in on that. And then finally, the last feature I want to talk about is the it's the trigger custom events in Kaboom.js. So custom events are a way to make your code cleaner, and so you can trigger those events. They're similar to signals in Godot. So I recommend reading that that blog post here, custom event in Kaboom.js, which is applicable to Kaplay. I might actually edit the titles and put in Kaplay/Kaboom.js. So that's that. And that's it. I hope this tutorial was useful to you. Yep, so feel free to, if you want to dive into projects, you can, using just the knowledge in this tutorial and using the documentation and the playground. You can actually start working on your first game in Kaplay by yourself. If you want to see how we do things a bit more advanced, you can follow one of my tutorials. And yep, so I'm hoping to see you in future videos. So subscribe if you want. So if you want to learn how to transform your Kaplay game into a desktop downloadable game, you can watch the previous tutorial I did on that. So yeah, thanks for watching, and you should see on the screen a link towards the Substack and maybe a previous video. If you have any questions, feel free to ask them in the comment section, and also join the Discord for Kaplay if you want to. We'll probably have a faster answer here because there are more people willing to answer questions than just me. So yeah, so thanks for watching. Bye.